Greetings and welcome to a new video about nonlinear equations. We will solve in this example also a nonlinear equation of two variables, and we will also do that in MATLAB. So we have done in the previous video using the calculator, the graphing calculator. In this case we will see that also in the MATLAB simulations of how we can do that and what kind of a command you can use to solve such a system of nonlinear equations. Of course, we will work out everything step by step in our solutions. So let's look at our example. We have again a simultaneous nonlinear equation with two unknowns, with two variables. This is the example we will use here. And we have the x1 and x2 as the unknowns. Let's also designate them by the numbers, equation number 1 and also equation number 2. So we need to solve the x1 and x2. Okay, how can we do this? Let's look at the solutions. First, we start with the hand calculations and then verify these in the calculator and also the MATLAB simulations. So the first, we start with rewriting one of the equations here. I just choose the equation number 2. And you isolate there the x1 or x2. So I choose the x1, so the blue one. So cosine of x1 is equal to 1.4 minus the cosine of x2. So I will replace this cosine of x2 to the right hand side of the equation. You will have this, and I have now also the arc cosine of the left and the right hand side. And you will have this expression, which is then the third equation in our case. If I now continue and substitute this equation number 3 in equation number 1, we haven't used yet. We have the following expression. You see the cosine of 3 times this long expression, which is from equation number 3, and that is actually x1. And then the final, the second part of this equation number 1, which is then the plus cosine 3 times the x2. Now we have an expression which is only a variable of x2, so one variable, and we can solve this not by hand, but we can work it out using the graphing calculator or MATLAB in a minute. So we can say solve this using a solver. Now in this case we will the calculator, and that will give me x2 for this case 0.1060 radians. These are of course angles, so we can use the radians, but you can also say it is degrees, so it will be then 6.07 degrees. And this is the graph from the calculator. From the graphing calculator, you can see the curve is looking like this. And we have one intersection point here, and that is the x2. Okay. But we know there is also another solution, which is then the x1, and that is actually shown here. So in order to calculate x1, we can use equation number 3 by substituting the value of x2 in here. So if I do that, I will have x1 is equal to the arc cosine of 1.4 minus the cosine of this x2 in radians, of course. And we have a result in radians, which is 1.153 radians. And in degrees is at 66.1 approximately degrees. And that is the next screen, which is actually shown here. That is another intersection, which is an x1. So we have two intersections actually. And one of them is the left side, which is then the x2, and the other one is the x1. And in summary, we have these results. So x1 is the 66.1 degrees or 1.153 radians, and x2 is shown here as 6.07 degrees or 0.1060 radians. And this is now done using the calculator. So that is the first part. Let's also do that in the MATLAB and show you the command there. So the MATLAB command for this case is the following. So you can type in the command window or you can make a small script. This is the script I have developed. So you can see I made a V, a vector, which is my initial guess for the x1 and x2. So those are the initial guesses for my value. So I said, okay, it could be maybe 0.5 radians and 0.9 radians. So x1 is 0.5 and x2 is 0.9. That's just a guess. You can also say 0.1 and 0.6. It doesn't matter. And this is a command you can use. Again, this is just one of the options. You can also do that in a different way. F is then equal to this expression. You can see the following in the brackets here. You can see the first expression, the equation number 1. which is set to 0. So it is cosine 3 times, and x in parentheses 1. That is actually your first unknown, the x1. The other one is x parentheses 2, which is your second unknown, which is then x2. The other one, the next one, is the cosine in a similar form, but then you have a minus 1.4. So this 1.4 on the right hand side is placed on the left side, and we have an equation which is equated to 0. That is the format you need to use. So you need to set up your equations in such a way that you have on the right hand side or left hand side, it doesn't matter, zeros. And that is the way to put it in this format, in this formula. Then we can use fsolve, and then this is the function, and then comma, the initial values we have chosen here. And if you now run this script, you will have this value. So you can see here, 0, so the answer is 0.10, so 0.1060, which is the x1 in this case. And x2 is producing as 1.1532. By the way, it doesn't matter which value is x1 or x2, because you can take this as x1 or x2 and then replace this as x1. So this doesn't matter. So we have these two solutions, and we can see that these are indeed correct as we have calculated. So we can see that it is also verified. Let's also see that in the calculator also, how we do that there, and also in the MATLAB itself. So in the MATLAB command itself and also in the script. So let's now jump to the first the calculator and also the MATLAB. Alright, we are now here in the calculator, the emulator for this graphing calculator. You can see the formula in the y1 entry, so that is this formula. So let me bring this to the left side, the right side, so let me make it a little bit larger. You can see this expression here for y1 here is this one. So cosine of 3, arc cosine 1.4, etc. That's actually shown here. So that's the first part. So let me go to the right. You can see that everything is here. The second one is 0, so this is actually the right hand side of the equation, which is y2. Now we can use now the intersection option of this calculator to calculate the x1 and x2. So what we do is then the following. You go to second, or first let's draw this circuit, or I mean the graph. So let me first draw it. This is the graph actually from this expression. So the left side is this one, and the right side is just the 0, which is then above that, and it's just going through the horizontal axis. If I want the intersection here, this is the one of the intersection, which is actually also shown here. The right hand side is actually shown here. So in order to get them both, we can use the option intersect, which is then second intersection here, which is then second calculate, and then option 5. So I click 5, and then he's asking me, okay, which curve is the first curve? So I need to move to the intersection where I see the intersection, which is then one of them is here, the other one is there. So let me start with the right hand side, right part. So the first curve is the curve I'm actually in here, which is in this one. So if I click enter, it will jump directly, automatically to the second curve, which is now y2. I click again enter. He's now asking me, okay, what is your estimation, what's your guess of the solution? Now this exact solution might be approximately here, so I click again enter. And I will now get here 1.153, etc., which is then this exactly. So you can see the screen, and this is also what we have calculated. So 66.1 degrees when you convert this from the radians. The other one, you can do again exact same procedure. So let me first go there. So you click first trace and then move towards that solution, the intersection. And again the same repetition, second, calculate, so on trace, but that's first, second, and then choose the option 5. And then he's asking again the first curve, so we do enter, and it will jump automatically to the second curve. We do again enter. We already know that we are in the vicinity of the solution, so let's just click enter again, and it will give me this. So this is the 0.1 0, 5, 9, etc., which is, let's look at this screen, which is this one. So again, we see the solutions, and these are again verified. So these two are from this graph. So let's also now look at the MATLAB. So see how we do that there in the script and also the solutions there. Here we are at the MATLAB script I already prepared for you. We have discussed this in the slide presentation. You can see the script, which is then this is the initial value. This is our function with the formulas or the expression for the first case and the second case equated to 0. Okay, and this function, this command in MATLAB will then solve the solution for you where we use the initial gases values for x1 and x2. Okay, let me run this. I will run this and I will get the solutions right away here on the left side. You can see it is now 0.1060. The other one is 1.1532, which is also what we have calculated. But if you, for example, take another estimation or another guess, let's see, let me make it 0.4, and the other one maybe 0.75 or 76, doesn't matter, and I run again. What happens? Now you can see something is a little bit changing. It will be a negative here, but that doesn't really matter because we know the cosine of this 3 times the, let's say, the negative value or the positive value will be the exact same, because the cosine of the minus x will be equal to the cosine of plus x, because it is symmetric, so the y values will be exactly the same. So it could be the case that you get the negative value, but it doesn't really matter because the solutions are correct. Now we can also say, let's do this 0.6 and make this, for example, 0.84. I just make random values. You can see now it is again positive, so really determines how you start with your initial values. Let me do another one. Let me make it 0.1, and the other one all the way to maybe 0.92. There's a very large distance between them. Now we get again that minus sign. It really depends on the initial gases. Okay guys, this is for this example about the solving a system of nonlinear equations having two variables. We have seen the calculations, hand calculation, also how we can do that in the graphical calculator, and also how we can solve this in MATLAB. When you have more than two unknowns, then an iteration process or method using Newton-Raphson method or any other method will be required to solve this. So then we need the Jacobian matrix, etc. So that will be a little bit more complicated. If you have any questions about this example, please let me know. I will try to answer them as soon as possible. See you next time in another video. Take care.